We got our dice, graphs. Looking good? I'm going to change my window back so it starts at 2. Here we go. So you got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why you had to set your max to 13, otherwise you'll lose that bar. Cool! Did you guys go one more stats? Did you want some one more stats on this one? Yes. Make sure when you do, you include L2. Don't forget that. Don't forget L2, otherwise you're going to get results if you don't. They're just going to be meaningless, right? If you just do one more stats, it's going to give you an answer that means absolutely nothing. So, there we go. We got an average? Yes. They're calling it X bar, and that's fine. The TI doesn't know that this is a population. You can call it mu. Okay? So this right here, this average is a perfect 7, but we knew that was going to be a 7 off the bat, didn't we? We knew that was going to be a 7 off the bat. We knew we could tell it was perfectly balanced around a 7. The standard deviation, though, that 2.4, that one's a little bit weird. That one's a little tricky to do manually, isn't it? That one's tricky to do manually. Your standard deviation is about 2.4. You can round that any way you want to. You can call it 2. You can call it 2.4. My question to you is this. I want to fuse some ideas together here. Based on that, based on those results, the mu and the sigma, and based on that, what would you consider unusual sums on the roll of 2 dice? What would you, and quantify it for me. Nathan has a vote for, he calls snake eyes and boxcars unusual. Snake eyes is double 2s, boxcars double 6s. Lauren, go ahead.
I agree.
Oh, you're agreeing. Okay, Sarah's agreeing too. Good, good, good.
And even, well, I guess,
Go ahead.
with our standard deviation stuff, with the 2/3 and 95%.
Good for you.
We would have to figure out exactly what's on the outside.
Well, let's do that. Once we have the numbers, we can actually do that, can't we? So here, we know this is 7. And that's mu. Now we have to measure mu and deviation from mu using the deviation. That's the whole point of having it, the 2.4, yes? So using the 95 and the 68, I love. This is not a perfect bell curve. Did everybody see how this is not a perfect bell curve?
It's like a pyramid.
It's exactly a pyramid. We're going to come back to this in your last exam. We're going to generate the equation in Excel in your last exam, which is not due for like 8 weeks or something, whenever the class is over. But the idea is it's a perfect right triangle. It's actually beautifully linear on both sides. It's bellish enough to treat it like a bell curve, for sure. But it's more exactly the perfect pyramid. But it's a little too fat in the tails. A bell curve tapers more. It goes shoot and then it tapers off. This one actually goes straight down, shot, like a pyramid. So, that's mu. It's bellish enough, though. So if you go out to mu plus 2 sigmas, and if you go down to mu minus 2 sigmas, that's your 2 standard deviations, plus or minus 2 standard deviations. If you do that numerically, you go up to, so 2 of these would be 4.8, yes? Mm-hmm. Plus that would be 11.8. That brings you right up to, right up to 12, doesn't it? Especially if you round, it rounds you to 12. So then you have to decide, is 12 unusual or not? Well, technically speaking, mathematically speaking, it's outside of 11.8. So you could say, yes, it's an outlier. But somebody else is going to say, yeah, but it's so close, it's just the top end of unusual. And that's fine too. Nobody has a formal definition for an outlier. We've talked about 2 ways of measuring it, yes? With what we're doing right now, you can also slap a box plot up there, which we can do in a minute if you want to. So there's ways of deciding whether or not you think this thing should be an outlier. Based on that, since 12 is outside of the range of 2 standard deviations, it's technically mathematically an outlier. So is 2, isn't it? Because of symmetry, if you go down from 7, 2 of those, you're down 4.8 from 7, which is 2.2 because it's so tight. 2.2, 2 is just to the left of that, isn't it? Now, somebody's going to argue correctly that 2.2 rounds to 2, and 11.8 rounds to 12, and therefore 2 and 12 are fine. And guess what I'm going to say to you? Totally fine. Your opinion. Outliers are not a fact. They are a quantification. They're a quantification. Depending on how you quantify it, you might get slightly different results than your neighbor. So 2 and 12 are the endpoints of that interval, or just outside of it. So they're definitely getting to unusual if they're not there already. Did anybody put a box plot on top of, the modified box plot on top of the histogram to see what it looks like? Let's do that too. What the hell? This is a freebie way of doing the IQR way, right? IQR, if you set up the modified box plot on the data, it'll start a box plot, and it might look kind of crappy. Let's take a look real quick. Yeah, we have to adjust the window a smidge. I'm going to make Y max be 0.5, 0.3. That's not bad. But it says no outliers. It says no. It says 2 and 12 are not so big to be unusual. So you can see how there's a slight disagreement even within outlier methods. Why? Because people made up the rules. It's not science. It's a way to try to quantify outliers. There's another way that some people sometimes use. I told you there were 3 ways I wanted to talk about as the course went on, 2 of which we already saw. The third way is just look at the distribution. What happens the rarest? Well, if you look at the distribution, which are the rarest outcomes? That one and that one. But now the next question is, what defines
Rare.
Thank you. What defines rare? How many of you are Soc, Psych, HDFS majors, elementary ed, maybe nursing? You guys read journals in your classes? You ever have to read research journals in class? You ever see something called a p-value in those research journals? What is it often shown to be less than? Do you remember? 0.05, which is 5%. That is a very commonly used measure of rareness. Anything that comes in less than 5%. You can feel free to use that one too. Any probability that comes in less than 5% is considered rare enough to be considered unusual. Guess what? Less than 5%, less than 5%. Everything else, over 5%, therefore it's typical enough. Isn't it amazing how they're all kind of agreeing with each other? Except for the box plot, which is set on something different. But that 2 and 12 being just outside the range are also just under 5%. Kind of clever, huh? So there was a bit of 244 there, I apologize. A little bit of 244 coming at you too as far as that goes. But that p-value of less than 5%, again, is a measure of rarity. How rare or how frequently does something happen? That means that these chunks here essentially represent the other 95%.
Does it fall within the 2?
Yes! There's your 95% of usual. And these are your tails of unusuality. Now, technically speaking, they should be 2.5 to 2.5%. It's not perfect. If you remember the... Actually, let's see how Excel's doing, shall we? Let's see how Excel's doing with our... Because it gives us decimals, too. And it gives us a nice little look. Let's slap Excel up.